Okay, so I'm Matt, recording another interview for the Zero to ASIC course, and today I'm very happy to be joined by Dan Rodrigues, and that's Rodrigues with an S, not a Z. And so, Dan, maybe you can just introduce yourself briefly.
Yeah, sure. My name's Dan Rodrigues, and my professional background is mostly in software engineering. That's high level, low level software, some bare metal software as well. The interest in bare metal software is how I got into the whole FPGA digital design thing in the first place. So that started way back in '08 or '09 with a Digilant basis board with a Spartan 3. That was fun. VGA port, tons of stuff, heaps of fun to play with. The Xilinx ISE tools were not as fun, but that's not a problem anymore because we've got these nice open source tools with the lattice parts. So it's much more fun that way. And it's a convenient segue into the ASIC stuff since the FPGA stuff with all the digital design. That gave me a decent foundation to, I guess, deep dive into the ASIC stuff since I had a nice platform to work from.
Yeah, so you were one of the 40 slots that went in on the first shuttle. So how did you hear about the opportunity to get involved in that?
Yeah, I think it came up on the 1-bit squared Discord at some point where oh, we have this ASIC thing. Here's an ASIC channel, and I saw the Sky 130 announcement way back. At the time, I was thinking, oh, that sounds pretty interesting, but oh, there must be a lot of time invested needed to get up to speed with the tools, any teething problems with the whole process, and so on and so on. I was making a FPGA project called iStation 32. It's this retro-inspired games console. I think someone was nice enough to take the video call, which included a sprite generator, which was what my shuttle submission was. They ran it through the open lane flow and said, "Oh, this thing is tiny. It takes no space. You should give it a go." And I thought, okay, fine. Let's give this a shot. And yeah, I guess that's where we got into it. The sprite generator from that project, the FPGA project, is pretty much the basis of my shuttle submission.
Okay, so you already had like a fair amount of work already done. The stuff that you had to learn was the like the open lane flow and how to integrate in Caravel and how to do the submission.
Yeah, that was the bulk of it. It was nice having pretty much an FPGA project ready to go. It's simulated, it's verified, it works on hardware. It's hopefully not a huge pain to get on the ASIC flow. And yeah, like you said, it was really just the open lane flow, getting my head around that, working through any bugs or crashes or any surprises along the way, and there were a few. But yeah, it really helped considering I had pretty much a month to get something ready to submit for the shuttle. So having something ready to go, it's simulated, it's something to work from, that really helped.
How long, you said like it took you a month? Was that kind of like part-time work? Like got any, can you remember kind of how much work it was to get something ready?
It was a fair bit of work, but that month was, say, an hour or two on an evening here and there, just bits of spare time, since I had full-time work with completely unrelated things
Hmm.
going on at the same time. A lot of it was pretty much, I would say it was 5% just the HDL stuff, getting the wishbone peripheral stuff and all the rest of it working for Caravel. The other 95% was, oh, what's up with this DRC problem? Why is the power grid not connected? Why am I getting this other issue? Just all the little things at the fringe. There was a fair bit of effort needed to fix all of those problems, but yeah, I expect it to be a lot less painful than next go around because with the newer branches on Caravel and OpenLane, it seems that a lot of it is now done automatically. A lot of the crashes and bugs that were there that got a lot of people complaining in Slack seem to have been resolved now. So it seems like most of the teething issues are solved, which is good news for everyone else for the next shuttle run.
Yeah, that was another question I had for you. Are you going to be applying for the next shuttle?
I have a few other things going on right now. The deadline is actually sooner than I was expecting.
June the 18th, yeah.
Yeah, it's pretty close. I have some audio and video stuff that I'd like to maybe get onto the next shuttle if it's possible.
Hmm.
If not, I think there's more shuttle runs planned after this, aren't
Yeah,
there? There's
another
at least one or
4.
two other
There's 6
confirmed.
in total so far, yeah.
Yeah, right. So if you miss this one, there's an opportunity or two later on. So I'm not too stressed about it.
Okay. So just one other question on the open lane thing before we move on and talk a bit more about what your submission actually is. How, if I did a diff of your the config that you use to harden the user project wrapper against like the one that came in the repo, how much customization did you have to do to get it to work?
Do you mean in terms of the TCL configuration, or just the user project wrapper, or?
The configuration.
Oh, right. That was actually one of the trickier bits. The power configuration in that TCL file needed a bit of customization.
Mm-hmm.
I think when I used pretty much the out of the box one, the tools pretty much said everything is fine. There's no problem. LVS passed. DRC checks are, well, they're not zero, but they're the number that we expect to get, right?
Yeah, the 75 or whatever that was. Yeah.
Yeah, whatever the number was, 75. And then you open it up in Magic or K-Layout and you see, oh, well, it looks like it's there. Everything's hunky-dory, right? And then you zoom in on where the power grid is. It's like, oh, the wires aren't there. Shouldn't there be wires there? And then I think it was either yourself or someone else said, oh, the power's not plugged in. So the chip's there, but they'd all be DOA because the actual the wires that would connect to the power grid, they're absent. And the tools didn't catch it at the time. So,
Yeah, I
oh
had
no, I'm
exactly the same
actually not
issue.
done
Yeah,
yet.
yeah,
I think a few people had the same problem. And later on, they actually did add the LVS checks to go, hey, the power nets are in fact connected. But early on, even when the submissions were open, I don't think those checks were there. So people were submitting things that were just not powered at all,
yeah.
which was a bit of a surprise.
And did you do a gate level simulation? Because presumably that would have caught like a disconnected power problem.
Yeah, it's yes and no on that question. For the gate level sim, I did have it working with the same PNG generation screenshots I have on my repo. That all seems to work pretty well. The only gripe I have is that it is unbelievably slow.
Yeah, I
So
bet.
I'm someone who's used to verilator and CXX-RTL, and they're like 1,000 times faster. With
Yeah.
iVerilog, you're sitting there waiting a good 40 or 50 minutes to get one frame. So there's a bit of patience involved, but yeah, it's something that we just have to do it. It's part of the process, and if you can't get gate level sims working, then why would you expect the chip to work? So it's just something you got to do.
Okay, so we've kind of been hedging around what your actual application is for a while, and now we're talking about frames. So it's pretty obvious it's a video application. I've just got your repo loaded up on my screen now. Maybe you can talk us through what VDP-lite is, what the aim is.
Right, so VDP-lite is pretty much it's a wishbone peripheral that generates sprites and outputs the results on a VGA-like interface. Right, so the idea behind this is, so you have those screenshots there, right? But there is no frame buffer that actually you plot pixels to and it goes out the VGA port, right?
Too
So
big, I
this is
assume.
I'm sorry.
Too big, I assume. Too like doing
Oh
because
yeah, that's
you didn't. It was difficult integrating memory in the first round, and then DFF RAM for an entire frame buffer would be too huge.
oh
So
yeah,
is
it'd be
that
prohibitive. It'd be
yeah?
enormous. Like
So you were racing the
even
beam.
oh yeah, it was very much a racing the beam approach where the basic idea is that you have a double buffered setup, but it's not double buffered in the sense that you have two frame buffers. It's double buffered in the sense that you have two line buffers, which is pretty much the same concept. But the idea is that every single line, you iterate over all the sprites in the sprite memory, and you see, does the raster position overlap with where the 8 pixels or 16 pixels of height of the sprite would occupy? And if it does, the sprite ID and the intersecting line with the raster gets put on what I term the hit list. So the sprite ID and the Y intersect go into this hit list. And what the hit list is pretty much a null terminated list of sprite IDs that I need to go fetch graphics for because it overlaps with the raster. So on the following line, I would iterate through the hit list. Like, oh, I have sprite ID 4 or whatever, and I have line 5 of that sprite to fetch. So I would go off and fetch the graphics for that line. and a bit of other attribute memory would have the or the glyph or the tile number that has the graphics to fetch. So I'd say get line 6 of that graphic tile. And I would fetch another sprite attribute which would have the X position. So once you have the graphics and the X position, you know where horizontally on that line buffer you must start blitting pixels, right? So I would blit the 8 pixels just horizontally, not vertically, because the line buffer is only for one line. So the 8 or 16 pixels get plotted, and then on the next scan line, the result of that line buffer will be sent out the VGA port. And if you imagine this process being double buffered and being repeated for every single line and a toggle on each line, you can just get 480, 520, 640, 800, however many lines you want using just 2 lines worth of memory. And that was enough to get it to fit into this synthesized flip-flop memory. So it's not even the pre-hardened macro blocks with the dual port RAM that some people were using. It's just synthesized flip-flops. So it's completely randomly placed. It's a mess. It's not very dense, but the good point of this approach is you don't need much memory. So I could get away with that.
So did you? You said it was 300. No, 640 by 480. So does that mean that you needed 640 times 2 flip flops?
In this case, I doubled the pixel width to take the requirement from 640 to 320. And then I guess I'd say letterbox or add pillars on the left and right side. That knocked it down to 256. So with those measures in place, I could reduce it to an 8-bit address. And because the color depth per pixel is only 2 bits, I think it was 512 flip-flops from memory, and then twice that for each line buffer, right? And if you try to push beyond that, I found that tools either took way too long, or it just took too much space, or Triton routes, I think it was, it just took forever to route, because these aren't neatly arranged grids of flip-flops. It's just whatever the
clouds.
They just end up where they end up. It's like just a spray gun of flip-flops. There's no order to it. So
I'm just looking at the GDS of the user project wrapper on my screen, and it's interesting how things get laid out. I can see there's like distinct clouds here, like a very dense cloud, and then have you got any idea where actually I can find out myself if I turn on and off the flip-flops. That's actually not.
That's interesting. I don't think I've ever tried filtering by flip-flops. I'm guessing one of those large clouds, or 2 of them, are where the 512 flip-flops are. And there's a few more for sprite memory and attributes and all the rest of it.
It's quite, I feel like I could, if I spent a bit more time, I could find out where they were. They look fairly evenly distributed. Yeah,
it is interesting how they form those clouds, like you say. You get like those oval or circular shapes where, well, these are clearly related, but didn't know what they were. And I guess one of them is probably the character ROM as well, since that takes up a decent bit of space too.
Okay, yeah. So here we go. I've just hidden pretty much everything apart from the flip-flops. Yeah, they look like they're fairly evenly strewn.
They probably take up a decent bit of space, right? There's only 512 of them, but
yeah,
they're just randomly placed.
Yeah. Okay, so and just for people that haven't done a video project, the more normal way in more modern hardware where you've got more memory is where you have a frame buffer. So and you have 2 of them for double buffering. So the graphics engine, whatever that is rendering one whole screen, and then when that's ready, the whole the pointer changes. So then the VGA driver is outputting from the second screen. And then you've got the other one that you can wipe over and regenerate all your output on. But as you explained, memory is a premium in this layout at the moment because the density for memory is so low, so it takes up so much space.
Yeah, that's right. And you mentioned clearing the screen there. It's kind of the same principle, but you just need to be a bit I guess, creative in how you manage the process of clearing and blitzing, right? So for clearing the screen, to make it work with the FPGA design in the first place, as you read pixels from the line buffer, it's almost like the erase head on a cassette tape. There's like an erase head immediately behind the read points, and it will just write transparent pixels right after it reads it, right? So it
Yeah, and you've got
was
to
like,
get that timing exactly right, or you get all kinds of weird problems.
oh yeah, you get, if you try to say erase at the same time you read, you get problems. If you obviously forget to do it or you screw it up, you'll get garbage pixels that were meant to be erased before. Yeah, there's and of course it has to be aligned with the raster beam, right? So you don't score any points for doing it early because there's no frame buffer. And if you screw up and you're too late, well, you can't just tell the TV, hey, can you rewind the raster a bit? It's too late.
You've got that stuck timing, and that's one of the reasons why they're like doing VGA stuff is quite an interesting FPGA project, I think, because you're like really, if you tried to do that with a microcontroller or something without dedicated video hardware, you kind of use up all of the CPU just trying to meet the timing, and then you don't have any space to actually do the cool stuff. So
Yeah, that's right.
you said you've got a link with the wishbone to the Pico RV32. So how does that play a part? Is that can it load sprites off the SRAM and then put them there and then control where all the sprites go? Like how does that side of it work?
Yeah, you more or less covered all of it. In terms of memory that the wishbone bus exposes, there is I think it's three banks of sprite attribute memory, such as the X position, the Y position, and which glyph you want to show, whether it's an A, B, C, or some custom defined character. And then on top of that, you have the palette memory, since it is color indexed. So there is I think with the IO limitations we have, there was enough to make 12-bit RGB, so just 4 bits a channel to keep it simple. So there's some palette memory so that the CPU through the wishbone bus can define what those palettes are. And then there is also one of the little stretch goals was to add some user-defined characters, right? So there's like a 32 by 32 pixel, very small synthesized memory where you can define your own tiles, right? So if I got the chips back and hopefully they'll work, I could make like say a simple 3D space shooter game where you did the old trick where the further away an object is, you just have a smaller sprite or graphic, right? And the further it is, you draw a bigger graphic. So you can make, even with the limitations that there are, you can be a bit creative and see what you can come up with, almost like a demo scene thing.
Yeah, so that does bring me on to another question I had was do you have any projects planned for this? Have you started writing firmware for a game or something?
I haven't got around to the firmware yet. What I really wanted to do was,
Classic.
as it happens, right? Oh well, the PCs get made. I'll get to the software. Yeah. Actually, before that even happens, I'd like to. I'm assuming at some point they'll release the footprint for the carrier board that eFabless is going to come up with, right? So I'd like to make a custom PCB that just breaks it out to a VGA
Yeah.
port. And I don't think I mentioned it yet. There are a pair of serial interfaces where you can just plug in an old Nintendo controller or something, an NES controller. So two people can play it with some old school controllers, which I think would be nice. So I'd like to make a PCB for that first, and once I have that, I'll see what games I can come up with. I have a few ideas.
So just on the topic of the PCB, I'd like to give a shout out to Sam Littlewood because he's already got a PCB that he's designed with the footprint. So what I'll do is I'll send you a link to his repo, and you can fork it as a starting point while
Yeah,
we
right,
wait
that's good
on.
going by Sam. I didn't realize
Yeah,
people were
he's
already starting with this.
well. A lot of information was actually in the data sheet, but probably you, like myself, only read the stuff that was absolutely critical for putting together a submission, and none of
Mm.
the PCB stuff. But Sam's actually read about the kind of the boot process and how you connect up the SPI flash and kind of what the programming interface is and all this extra kind of stuff. So it's definitely worth a look at what he's done there.
All right.
Yeah, so you're going to have like 50 of these ICs. Has anyone approached you for like asking for some samples so they can make some custom games with them?
Not yet, but I'm happy to hand some out.
Okay.
It's one of those things where I guess it's like the ICE40 FPGAs where you don't have that much to work with, but part of the fun is trying to squeeze what you can out of a limited resource. And I'm all about that. So it's the FPGA stuff I mentioned before. Try to milk the most out of what limited resources you have. Don't just go to the larger, fuller
Yeah.
featured part. That's part of the fun. So yeah, as soon as I get those chips, I'm keen to see what I can squeeze out of it.
That's one of the interesting things about creativity, isn't it? Is it you kind of you need the limitations, and then people get super creative about getting the most out of something, or being like super creative when they're working within limitations.
Yeah, 100%. Like if the ceiling is too high, you're not motivated to reach it. But if you can just reach the ceiling, it's just almost there, then you're more motivated to make a shot for it, right?
So I think let's now talk about simulation. So I asked you earlier to pick one of the topics in the terminology section of the Zero to ASIC course website, and you chose simulation. And I think that that's like it's quite a crucial part of putting together a submission, but also it's quite. I've always found doing simulation for video projects especially tricky because of the time involved. You know, you have to have so many clock cycles to render a frame of video. So, could you talk a little bit about whether you said that you'd already done some tests on an FPGA. The hardware came from another thing that you're working on. Did you also try putting Caravel into an FPGA? Did you try it with Pico RV32 and the wishbone? And after you've mentioned the FPGA side of things, could you tell us a little bit about what you did on the simulation side to check that everything was working correctly?
Right. So I didn't try taking Caravel and putting it on an FPGA. That's an interesting idea. I think a few people have floated the idea, but I don't know if anyone's actually followed through on it. I think
I did manage to do that, but not with all of Caravel. I just took out Pico RV32 with the wishbone and the logic analyzer, and then put my user project wrapper inside that. So then I could test some simple firmware where over the serial, I could interact and enable and disable each of the little projects. And because one of my projects was a video project, I was able to actually see the output on a VGA monitor, which gave me some good confidence. Um, so you said that you did some testing on an FPGA with your project beforehand because it came from that. Um, but for Caravel, you did mostly simulation. Can you talk a little bit about your kind of simulation strategy? How did you do the testing?
yeah, right. So for this project, I more or less had a let's call it a VGA state dumper, which pretty much for every single clock cycle, it would just dump the state of the VGA pins to a file, and it would just keep a pen in the state for each clock cycle, right? Then if you wait long enough, the 40 or 50 minutes or so to get a full frame, you will have enough VGA state to run it through a Python script, and that will generate a PNG file of the frame. So that's not ideal in terms of time. I could have done something similar to what you have, where just extract the peripheral with your VGA controller, and I guess add the scaffolding yourself such that you don't need Caravel. So that's something I might do for a future shuttle submission. What I've done for the original project that I took this VGA controller from was pretty much make a verilator test bench, which would be much, much faster than using iVerilog, about 1,000 times faster. And a fairly bare bones way to do that would be to just, you could have C++ code that just drives the wishbone transactions manually. So just assert the address, the wishbone strobe, wait for the acknowledge signal to come back and all the rest of it. And that will be one way where you don't even need a CPU. So if you just wanted to focus on testing just the peripheral, no CPU, that's pretty much what I would do. That's worked well for other projects in the past. Or I could do the FPGA strategy that you've came up with for your own project. So yeah, there's a few ways to do it.
Yeah, I had a nice pull request on my VGA clock example where a verilator test bench was added, and that lets me run the video at real time and even like adjust the minutes and seconds and stuff with the keys. So that was super cool.
Mm.
I just like to mention who that was. That was Diadatp. So thank you for the pull request, and I post a link to this repo in the video description if you want to check out how they did that.
Nice.
Could you say anything about the way that you structured the simulations and the tests inside Caravel? Was that straightforward, or how did you get along with that?
Right. So for the Caravel test structure, if you saw the project repo, there would be a test for the video frame, the gamepad, and I think one or two others. So the basic idea was to I did the typical strategy where I have an includable makefile in the root level of the project, and I would pretty much just put all the core makefile variables, the main peripheral, and just try to customize the least amount that's needed. And trying to use, I guess, reusable test modules. And by test module, I mean, say, for the video frame, there'll be one module that just does the RGB state dumping. So you don't just need to copy paste the same thing over and over again. And yeah, pretty much any strategy that would minimize the amount of boilerplate you need to write for each individual test case would go a long way here.
From a project called Ice Station 32. Where can people find out more about that?
Right, so that's public on my GitHub profile. So if you search for iStation-32, it should be the first result. So that is an FPGA project that you can run originally on an Icebreaker, the 1-bit squared product with the DVIP mod, and you can also run it on a ULX3S. So those are two popular FPGA boards that you can buy and run with the open source tooling. So if you want to get your hands dirty or just fool around with some retro inspired hardware, that's one way to do it.
Looks really cool. Actually, seeing some of the terminology there reminds me a bit of the Hackaday SuperCon badge, because there was a similar kind of retro sprite-driven video hardware built into that.
Yeah, that's a cool one. I would eventually like to make an actual, whether it's a handheld or a standalone game system with controller ports and such. Eventually, I'd like to get around to that. That'd be cool.
With your own ASIC inside.
Oh, that'd be nice.
Yeah, so I really look forward to getting hold of a sample and being able to play one of your games on a custom chip. That would be great. Put me down as a demo tester. And just as a last question, could you recommend any resources for people wanting to learn about this stuff further?
I'll recommend the same way that I learned about it at the start. If you pick an old real game system, whether it's the old Gameboy or an 8-bit Nintendo or a Super Nintendo, just pick whatever interests you. If you search for technical documentation on that, you'll find that chances are it's pretty well documented. The tutorials are readily available. There will be plenty of getting started guides. There'll be nice amounts of hand-holding, tools to get you going, and probably a supportive community built around it, especially for the 8-bit Nintendo one. If you choose that as a way of getting started, you'll eventually find that there are patterns and reasons why the engineers did things the way they did, and that will give you some ideas on oh, that's actually, I think I see why they did it that way. That makes the hardware pretty simple, or that makes the hardware a lot easier to design. Like, there's a lot of sense to this, and eventually, without seeing the original schematics or whatever, I got an idea of oh, okay, I can see how these parts come together now. I'll just have a go at making my own interpretation of that. And whether you just stick to making software for one of the existing systems or you try making your own system, that's probably the best way to get started. Like, see what the real world examples did and find an appreciation for the way they designed things the way they did, because there is a reason they actually did design things the way they did.
Have you seen the Ultimate Gameboy talk on CCC?
The Ultimate Gameboy talk. No, that's new to me. What's it about?
There's a series of the Ultimate talks, and one of them was so they're an hour long each, and it was like a super deep dive into the Game Boy. It was on Chaos Computing 33. But yeah, so I can't remember if I watched that one or the Super Nintendo one, but that was definitely a very interesting video. I was just wondering if
Yeah,
you
right.
had
It
seen
sounds
it or
about
could
right.
speak
If
to
you
it.
want to
Yeah.
make your own, I guess, Game Boy inspired game system, that's the
Yeah.
sort of stuff you want to look at. That's a good one.
Okay, well, Dan, thanks so much for your time and for telling us about your project submission. Wish you all
Cool.
the best with the ASIC when it arrives, and maybe we'll get you on again to give us a demo with the real hardware.
Cool. Awesome. Thanks for having me, and thanks for your time.
Cool. Bye-bye.